What is up, guys? Welcome to another episode of CCT. Alright, so we're at day 20 of the Leak Code Challenge, and I wanted to record myself doing this problem. And yep, so let's just get started. So construct a binary search tree from a preorder traversal. Okay, so yep. Okay, so the preorder traversal looks like this. 8, so it goes from 8, 5, 1, 7, 10, 12. Okay, so preorder is going to the root. So the first thing is always the root. And then, if I'm going to construct a binary tree, I feel like I need the left side and the right side to like pass into some kind of recursive function. But now my question is kind of, how do I know what's on the left and the right side? Okay, and I think I kind of just thought of it. So, like, okay, assuming this is, yeah, so we get this input. This is the root, this 8. And then what's on the left is, so like I guess we would keep iterating through this, and everything that's less than 8 is on the left, right? 5, 1, 7, everything that's in this left subtree should be less than 8. And then once we get to something that's greater than it, then we start putting it in the next, the right subtree. And after we have these divides, then we probably will call this recursive function on this, and then it'll say, okay, the first thing in preorder is the root, and then let's see what's in the left subtree. So then we keep looking for things to the left, things that are less than 5, and then, yep, okay. Okay. So I'm always a big fan in Python to make my helper function, especially when it's like a recursive helper function that no one else is going to use, within this function itself. So I want this to take in a, oh wait, it is going to take in a list. Yep, never mind. So I would only make a helper function if the stuff that I need to take in is not this, but I actually do need to take in a list. So this function is going to be taking in some list, eventually sublists, and then returning the root of that constructed subtree. Okay, so let's just start with the meat of the problem. So we got this tree node, so let's call it root gets tree node of preorder at 0. We'll do checks in a second, don't worry. Then I kind of will just iterate through. Yeah, that's fine. So for I in range, let's give it 1 to the length of preorder. Okay, wait, let's define some things. Less than or left list, right list. Oh, yeah, that's not actually necessary. Yeah, I just want to find this divide. Okay, sometimes Python's for loops are a bit annoying. I kind of think I need to use a while loop in order to get the control I want. So basically, while I guess it would be preorder at I is still less than the preorder at 0, or we could do roots val. Actually, that actually is a bit more understandable, I think. I plus equals 1, but then, I mean, we also have to make sure I is less than the length of preorder. Okay, so hopefully I is the start of when it's bigger. Yes, so left list is going to be 1 through, and this is how you can make sub. It's preorder 1 through, I think it's exclusive, so I'm going to use I. And then the right list is going to get preorder from I to the end. Yeah, and if, I'm just wondering if it equals the length. That might be a problem. Okay, let's just say if I does not equal the length of preorder, then you can do this. Okay. Otherwise, so they're already set to none. Yep. Okay, so then we could do root. I was kind of just thinking of the base cases, but I'll get to that in a second. Let's do BST from preorder. I think this does need a self-dat. And then we could pass in the, let's start with left. Why are we starting with right? So left list. And then root dot right is going to equal, of course, very similar call. This is very classic in these search tree or BST kinds of problems. Okay, so then we can hopefully just return the root after that. Okay, so now let's get to the base cases. So it seems like we are going to allow left and right list to be empty. So if not preorder, which is the list, then just return none. Okay. Yeah, so I guess if there is something in preorder, then the protocol is to, if tree knows you get the first, yeah, so this is kind of protecting this next call because we know there's the 0th element. And then we make sure, so if there is only one thing, this is going to break it out. And then it's going to go from 1 to 1. That should just be an empty array. And then this is also going to be an empty array. And then both of these are going to return none. Okay, looks fine to me. Okay, great. So another integral part of what I'm trying to do is write test cases also. Okay, so they basically did this one. Okay, so there's a few ones that we should get out of the way. What does this happen? What happens here? Always good to test the empty one. And what happens here? Okay. Next, I want to do, so if this is preorder, dang, this is kind of hard to construct. So I want to do, Okay. Yeah, so if everything is bigger than it, if we have something like this, that means that, like, okay, 1 is the root, and then all of these are greater than it, then it's going to make 2 the root. Yeah, so this is going to be a stick. So that's what I wanted to test. So I think that's the same. Okay, and then just, of course, the reverse of this, which is the left stick. Okay. What else could we test with this? To make sure we're confident before we submit. I mean, yeah, if the stick works and then this kind of mixture works and the base case test cases work, seems good to me. Let's submit it. Yay! Alright, so that is LeetCode day 20 of the 30-day challenge problems. Okay. Alright, yeah, so I'll end it here, and I'll see you guys next time. Bye.